Good morning, everyone. Welcome to another episode of xah Talk Show. Today is 2019. Yes, indeed, it is. Hi, guys. 2019, November 30th, Saturday, and 10 o'clock, 10 after 10 in the morning. Good morning, guys. Emily and Papa Moon, Lunarus. So, what is today's topic? I have to wait. Let me open Discord. Oh, this is not all set up. Where is my Discord? Wait, what window is this, Brave? So Discord, and where is Spot? So what is today's topic? Randomness. Oh my God, randomness. Emily, Emily is putting major pressure on me. Randomness. I don't, I don't know nothing about it. It's a hard topic. So randomness, it turns out random is hard to define mathematically. In computer programming, we have a function in most languages that you have a function that generates a random number, and we usually call that a pseudo random number because because it is actually not random because it's algorithmic, meaning that the sequence it generates will be the same every time. And in fact, I run into that problem in real life in Emacs. Morning, Emily. Good morning to Emily to UK. And so random numbers. Yeah. So I run into that problem in Emacs actually. So if we go to my settings, so Emacs settings and search for random. So Emacs Lisp, just like any others, you have a random function, and I have several commands that does do random. For example, let me open a new buffer, and you see this is a random alphanumeric. So I have this xah-insert random string, then I have xah-insert random hexadecimal number, such as that. Let me show you. So I'm keep doing that, or I can insert a random decimal number. So I have these functions, very kind of useful, and they are useful for if you are programming, if you have a variable, you always add a random number into your variable name. One day I was doing an interview. This is about 6 years ago. I believe it's Coursera. Okay, Coursera. Okay, that's one of the company that does tutorials. They create tutorials. So I was interviewing uh, via Google Hangout through via video, and in about the end, everything seems so well, and I'm going to do a live coding of JavaScript. So I did that, but in the last step, I added a random string to all my variable names. and and that threw off the guy, and oh my god, and he's thinking this guy is not what we want, and that's the end of it. So anyway, so random numbers. So I have these functions Emacs about random numbers, right? And yeah, so this in Emacs functions. So let's look at where are they. Okay, so let's look at, so they are in this file xah insert random string, and then so this file is 100 lines, and let's search list matching lines, list or define. So we have insert random hex, insert random string, insert random number, and insert random UUID. Okay, that one we haven't demonstrated. Let's do that. Insert random UUID. Do I have a key for it? I'm not sure. So let's see. Describe function insert UUID. So describe function that, oh, I do have a key. So let's call it. There it is. Insert random UUID. Now UUID is interesting by itself. UUID stands for universal something something random. Basically, it's supposedly to generate an ID that is universally random. That is in the entire history of humanity. If you use this function to generate a random number, there will be no repetition, supposedly. So this UUID has this format, and you can look up on Wikipedia UUID. So let's do. So UUID generator, universally unique identifier. So that's what it's supposed to be. And another thing interesting about that is that they are actually using hexadecimals. They are not using, for example, random alphanumerics. They only limits the letters from A to hexadecimals, A to F. So anyway, so I have these functions that's interesting, and you can get them. They are on Melpa. You can get them by, this is the file name, xah-insert-random-id.el. Okay, so you can get that, and you see I have to set a random seed here. You see this line, random t. Yeah, because if you do not set that, then every time you call a random number, when you start Emacs, the number will be the same sequence all the time. So actually, we can demonstrate that. So why don't we do that? So let's go to shell. And okay, so let's see. So today's topic, is random, indeed, random, and the math aspect of random number is really interesting as well. But I don't really know much about that to talk about it. So Emacs, let's start Emacs. Emacs is always fun. So let's start Emacs. No init file. So start it. So you see we started Emacs. Okay. So now new buffer. Okay. Now this is Emacs. I don't know the default keys. Everything doesn't work. How do I magnify the font? Emily, how do I magnify the font? Good morning, Justin. Okay, so magnify the font. I suppose you go to, God, yeah, I don't know. This is gonna be a problem. How do you magnify font? Okay, so it must be in the options. I remember set default font. Okay, let's try it. Set default font. Yeah, okay, so there we have it. Let's say 14. Okay, regular Menlo 14. Yeah, okay, let's say try 18. So we are going to do, why don't you use batch with eval? For what purpose? Like what? You mean evaluate random numbers? Well, I think oh that's a good yeah, that's a good option. But anyway, we are already here, so let's just continue this. So what we're gonna do is we are going to generate random numbers. So buffer is text only. Ah, God. So I need to create a new buffer that will be Control X, Control B. No, Control X B. Okay, scratch buffer. Now let's call random. Okay, I don't have my keys and all. Random option limit. Okay, so random, we call the random option, I mean the function, and we evaluate it. Control X, Control C. Ah, that's that's quit. Shit. The proper key is Control X, um, Control E. Okay, so let's do what Emily says. Let's try this. No, okay, eval, and in text scale increase font size. Okay, I'm not sure this is gonna work because I'm in unknown territory, and the thing we want to avoid is that I'm trying to figure this out in for 10 minutes in my talk. Just to get this. Do I need wait, do I need the single quote? I do, right? Let's try that. Okay, okay, where, and I need dash q, so that means no eval my init file. Yeah, but if you use batch, like dash dash batch, then Emacs won't launch, right? Yeah, but I do want to launch Emacs, so let's try that. Yeah, I got an error. So, oh, wrong arguments. Text scale increase. Okay, let's figure it out. So describe function text scale increase. Oh yeah, so you need an increment. So okay, let's Control X, Control C to get out. Then let's do it again. Text scale increase increment. Let's say 2. Okay, do it. Okay, that's worked. That worked. That's great. So now we are going to try random. Random. Can you guys see me? Let's see. Oh, the video is screwed. Nothing. Did I just lost? Did I just lost stream because I quit by mistake? Control XE. Okay, don't screw up this time. Control XE. There we have it. A random number, a big one. Now we want to insert it. So Control U first, then Control X, Control E. There we have it. Let's do it again. Well, let's write a function. Let's just write a function. Now I don't have my key bindings and everything, so this will be painful. So set q x from 0. Let's just say, let's go the most basics. While x, okay, while x is less than 10, let's say 5, then we're gonna do, then at the end we want to no key binding is gonna be painful. Set q x equals to 1 plus x. Yeah, I think that work. When you do a while loop, if you got it wrong, then it's gonna be infinite loop. So usually that's painful, because if you make a mistake, you better be sure it's correct. Otherwise, it's an infinite loop. Right now, we are trying to generate a sequence of random numbers. So x1 plus x, that's correct, right? or we can just do set q x, plus 1 instead of using this. Anyway, I think that's correct. Let's evaluate it. Let's hope that it's not infinite loop. Okay, Control X, Control E. Error, void variable X. Of course, don't worry about that. Evaluate that first, then Control X, Control E. That worked. Okay, now we're gonna do print random. Okay, let's see if we can get this. Now I don't have my keys, so everything is a struggle. Let's see. Yeah, okay, so if we do that, let's see what happens. Control X, Control E. It seems to work. Control H E to bring up the message buffer. Now the message buffer is not, the font is too small. Anyway, so this is not working out. But anyway, so you see, when we call the random the first time, it gives us this number 22215 something something. Okay, remember that. Okay, let me copy that. Control X, Control space to mark, then copy. What is copy? Copy is meta W, I think. Meta W. I hope we got that. Then we are back here. Then create a new buffer. Yes. Okay. So now let's switch back and exit. Control X, Control C. Oh, okay, that's okay. Let's try Emily's suggestion. we we going further and further away to the remote places of the universe, where I don't know what things are out there. Okay, so let's do that. So in order to do that, let's go to my home dir. Do I have any secret in my home dir? No, I don't think so. So let's go to my home dir and create a file. This file will be named xxx.el. Okay, and now we can write Emacs list to our hard content. Okay, set q, now it's going to fly. Set q x equals to 0 and magnify the font and show that. And while okay, let's not x then, let's I. While I less than 9, then let's do something here. And what we want to do is print I and yes, and open a new buffer. Open a new window. Show messages buffer. And we're gonna show the result here. Okay, we're gonna evaluate these lines and show it. Okay, so comment this out. Comment this out. Eval buffer. There we have it. Now it says 1 2 3 4 5 6 7 8. That's wrong. Oh, we should print random, not I. So let's do it again. 0 1 2. Where is my random? Oh, it's not printed. Okay, print, not point. Print random. Okay, eval buffer. Now I don't want the extra, but anyway, it printed out. You see, that's a result. So the first one is 2 1 something. The second one is that one. But there is one more thing. I don't want these extra lines in between. So to do that, we can use print C, I think. Let's just try it. Let's see what happens. Okay. Now in Emacs, this you have print T, you have print and print C, and you have print 1. They differ by, yeah, print C do not print the end of line, like a new line at the end. Then, but the print will just add a new line at the end. So in fact, we don't want to print I. Let's just make it things simple. So let's do it again. Do it. Okay, now it's a whole bunch of numbers. Now we need to we need to concact. Okay, concact the first string, then the second string is gonna be a space. Okay, eval buffer, wrong type of argument, sequence P, and then you need to turn the random number, a number type, into a string type. Okay, let's do that. String to number to string. That's what we want. Then random. Evaluate. Now we got what we want. One line. Here it is. One single line of a bunch of random numbers. Okay. Now let's try. Let's try to run that in the Emacs. In a shell. So let's do Emily's suggestion. So we want. Good morning, Bot. Bot is alive. So we want batch. We want batch, and we want So we want queue, and we want batch, and we want the file name. So that's gonna be tilde my home directory xxx.el. So if we run it, it should print out right in the terminal. I don't think so. So let's try it. Run it. No output. Because no output, because let's try messages instead of print. Okay. You need to save it. Do it again. No output. It should. No, I don't want bash. So it should. I forgot what. Okay, so xah's Emacs tutorial to the rescue. Go to my Emacs blog. Load. Okay. Let's listen to Emily. So Emily says load. Go to terminal again and load. Okay, so let's try it. Nah, you need okay. Actually, it worked. It worked because I saw. You see, it worked. Now, there we have it. Now, there's something interesting. Now, let's magnify the font. Okay, use backslash for directory path, so you don't use Unix. Let's see. Let's increase font size. Right, Emily is right, but now let's increase font size. Let's see what font. Where is font? Here. Okay, font. So the first random number is 2281665585 something. There it is, 2215. Wait, they are different. What I'm trying to say is that you don't see the random. Every time you run it, the sequence is going to be exactly the same. but 2281. So but right now it's not 2281. So let's do it again. Okay, so shut down, and Emily says use load and batch. Okay, do it. There we have it. Okay, now I need to magnify my terminal, and let's do it this multiple times. Let's see, and we don't need that many numbers, so let's say 5 times. Do it. Do it. Each time it's different. No, this is wrong. Oh, because wait, it is possible that Emacs version 26, or sometimes in the past 5 years, they have, each time Emacs starts, they added a random seed, but I don't think that's the case. You see, what we expect is that every time we run this, the same bunch of numbers come out, but they are not. Why is that? Let's try the most basic way first. Let's just see what happens. Okay, let's try the most basic way. So let me just do random. Okay, random. Let's just evaluate this. Control XE. So it's 178 something. 178 something. Okay. Quit. Let's do it again. Run it. No, it's negative 307 something. So it's not what I expected. Quit. Let's try Q. Okay. It's not what I expected. Wait. Okay, so now you need to switch buffer scratch. Okay, random. Control X, Control E. Now it's 427. So apparently this experiment failed. It's not doing what we want. That's interesting. So there must be some changes in Emacs in the past 7 years or so, because in the past 10 years, because I do remember, because right now in my Emacs init file I have a seed. Let's see what's the function. Seed random. What is the function name? What's the function name to set the random seed? We can see it here. There. So you call the random function and you pass t for true. That will seed a random. So I have that in my init file somewhere. Let's go to my init file. So search for random. Okay, OEL files, and let's see, where do I see it? Okay, it's not here. It's not there, but it's in this. It's in this. You see, it's in this package. My init file loads this package. So every time my Emacs starts, the random seed will be different. But about 10 years ago, I did not do that, and I was using calling random stuff, random function, and I noticed I was surprised because every time I got the same number. I didn't realize for a while, for like several months. Then I realized that. So I realized that Emacs does not set a random seed in the beginning. But now apparently it looks like it does now. Yeah, so that's interesting. And so that is about the Emacs thing. That is about the Emacs random seed. So I was saying the function, the random function in vast majority of programming languages, they are called pseudo random numbers because every time you call them, they give you the exact same sequence of numbers. Actually, we need to demonstrate that since we are talking about that. So let me try it one more time. Okay. Now what we're gonna try is to set the random to a can you set a specific seed? Okay, look into Emacs list random number for details. Let's see. Okay, so you can set a seed. So let's try that. Let's try. So Emacs documentation says that if you give it a string, let's say AAA, then that will set the seed according to this string. So if we do this, then the output will be the same. Let's see. So okay, so let's go to the shell again. Let's do that. Let's see if we can do that. So it begins with -201 something. Do it again. There it is. Do it again. There it is. The sequence of numbers are always the same. So that's about pseudo-random numbers. It just repeats because it works by an algorithm. Now, what else? What's the next topic? So actually, I've been, random number is, I learned apparently it's very complex, and you can go to Wikipedia and it will tell you a lot of things about it, quite a lot. Like the issue about random number, you can study 4 years. You can almost like get a PhD just by studying random numbers, all the concepts evolving, related to random numbers. But anyway, modern algorithm that generates random numbers are basically using this function. So you begin with a number that's called the seed. Then you apply the mod function to the x1. So x1, so let me magnify. So x1 is just a beginning it's a number you begin with. Okay, it's a number. So you call mod on it with two arguments. The first argument is a times that number, the seed, plus c. Then the second argument is a constant, some constant. So you do that one time you get the second number. Then you repeat. You put the second number into there. Then you repeat. You get a third number and so on. So that's the essence of modern pseudo random number generation. And Wikipedia has a lot of details. But anyway, the random number the concept seems, it seems like it's nearly impossible to define it mathematically. And I don't know how it is done. It's quite deep. The only thing, the closest math definition I know is this thing, Kolmogorov complexity. Okay, and you can read it here. I have written, I have blogged about it. Okay, so one of the concept of random number is statistical randomness. which is not true random. Uh, the statistical randomness, you can pass several tests to see if it's random in a statistical sense, meaning that, for example, it doesn't have too many repetition of a specific number or things like that. So that's statistical randomness. So in programming languages, the pseudo random number, they pass statistical randomness, but it's not truly random because, here we have a graph that plots a bunch of pseudo random numbers, and you can see they all lie in a plane. The way you do that is you take so you have a sequence of random numbers, and you group them by three. So you got three numbers, then another three numbers, another three numbers. Each three number is considered as the coordinate in space. Okay, so you got a bunch of points, and you just plot them, and they look like that. It's kind of they look like that. They all form a plane. All these random numbers forms a plane. So in this way, you can clearly tell it doesn't look random at all. And similarly, for if you just take 2 points instead of three and plot it on a plane, you got this regular pattern. But still, the thing about that is they pass the statistical random definition. They pass many statistical definition for randomness, but that's not true random. But so the interesting thing is, so how do you define what is a true random number in a mathematical way? Meaning that you have to define it via logic, modern math foundation, logic, set theory, and things like that. So how do you define a random number? To us programmers, we can say, oh, you just pass this. You just like unit testing, like the unit testing, stupid unit testing. You just pass it through several other functions to see if you know to see if it has too many tools, or some average is something not too big or not too small, something like that. But that's not mathematical. That's not truly random. You got problems when you study this in detail. You'll find oddities. You'll find oddities like that. So that is why the so that is why this is so puzzling. Random. The concept of random is quite puzzling. You have so there is statistical randomness, but we know for sure that's not random because obviously this is statistically random. But when you do it, it's not exactly random. So, but the question now is, but how do you define, mathematically random, the concept of random, such that this thing will fail? You can, if you apply your math definition, then this is not random. So how do you do that? So that turns out it's one of the deepest question in math or computer science. All these are about theoretical computer science. Yeah, that turns out to be very difficult. And the Wikipedia has tons of information. You can spend days, probably years to understand them. And the one definition I found so far is I don't like it. Okay, one of the definitions. So it says, here is what it says. By the way, we have many of these interesting things. Let me show you. Okay, so let me turn on JavaScript. These nerds have these dice, polyhedron dice, and there are some nerds who go extreme to test if these dice are fair. They throw it millions of times. So there is this guy who built this camera machine, and with this cup that just shakes the dice. He put the dice there, and the cup just shake it every few seconds. Then the camera takes a shot. So then he used image recognition to read the value of the outcome, the dice. So he does this millions of times, so he can find out whether that dice is fair. And he did a report. Let's refresh, okay. Then he did a report of this result, and you can read his articles, okay. You can read his articles here. I'm going to copy these links in my YouTube description. So after 3 hours after the stream, you can go read them. So this guy did a lot of tests on that. Anyway, so back to the math definition of a random number. We got this passage. This is very, very annoying. Like in computer science, many of you guys nerds, are interested is that there's entropy, and the concept of entropy. And also there's, this, I never really liked those concepts. Like I don't really, actually I don't understand it to be honest. But one day I was on Google Plus, Google Plus, which closed down like half a year ago. One day I was on Google Plus, and there is this mathematician I highly respect, and I was flaming the concept of entropy, okay, and he told me no, it's a good thing. So yeah, I suppose it is, but I never actually understood it. Why am I mentioning entropy? Because when it comes to, let's go there, okay. I'm gonna do a big rant on that entropy, okay. We are going to get back to the mathematical definition of random number. But anyway, let me just read it. So the closest definition I got is this, okay. Let's see, where is it? Okay, here. So it says, okay, hold on a second. It says algorithmic information theory studies, among other topics, what constitutes a random sequence. The central idea is that a string of bits is random if and only if it is a shorter than any computer program that can produce that string. Okay, that's a definition. That's kind of from a computational aspect definition. That's actually not a math definition. In math, at least the traditional sense of math, you don't define something by saying it's the shortest program. You have to define it entirely in pure logic. You can't say, oh, a sequence of bits is random if it's if there is no shorter program that can generate that string. If you say that, then you have to define, it's very loose. It's all English. You cannot do that. So in formal math, that's not a formal mathematical definition of random. But however, you can rephrase that English, into math. That's a thing. Okay. But anyway, let's look at this definition. Okay. So this is kind of a computer scientist way of definition. I don't like it. So it's computer, and this relates to Turing machines and all that. But anyway, it says, okay, so a string of bits is random if and only if it is shorter than any computer program that can produce that string. This is nasty. This kind of approach of definition is kind of nasty. Like, what do you mean? Short is there's no impossible to have a shorter program to generate it. It's too loose. I don't like that. I don't like this idea at all. But anyway, but however, remember that this English sentence, it can be turned into formal language, into the traditional math definition. So apparently this definition is called Kolmogorov randomness. Okay, I have put it up here, and if you try to read this is impossible to understand. Okay, this is, I know many of you, I mean, my followers, like programmers. Okay, they will say, "Oh, I understand," and no, I can tell you, if you don't have a kind of like on average a PhD degree in this field, you don't understand it. Okay, that's what I'm going to say. So anyway, so this Kolmogorov complexity. So it says in algorithmic information theory, the Kolmogorov complexity of an object, such as piece of text, is the length of shortest computer program that produces the object as output. This is badly written. This is idiotic Wikipedia. This sentence actually illustrates the one of the primary problem of Wikipedia. They try to be, they say object. They say, the Kolmogorov complexity of an object, such as a piece of text, is the length of the shortest computer program that can reproduce the object. This is fucking idiotic. They try to generalize it by using a calling it object. just fucking call it a number or a string, a sequence of strings. But these stupid people, they try to make it sound big. But anyway, I mean, that's just a problem with the writing style, and this is a kind of very typical problem of Wikipedia. It used to happen much more often. Today is much better. Like 10 years ago, this kind of problem, writing style problem, happens a lot more often. So anyway, so this article, this article is not short, and lots of references, and in it you'll see it references to many other difficult topics, such as algorithmic complexity. Then there is this Solomonov, Kolmogorov, Chaitin complexity. Then program size complexity, descriptive complexity, and algorithmic entropy. There it is, entropy. That's why I say it's related. Okay, this kind of topic. So I think 2 years ago I was trying to, I was reading this article, and and you can see it also mentions, it says the notion of Kolmogorov complexity can be used to state and prove impossibility results akin to Cantor's diagonal argument of set theory and Gödel's incompleteness theorem and Turing's halting problem. So you can see this is no trivial thing. This is quite deep. So you want to understand this, you pretty much have to understand all the others, or one of the other. They are kind of interconnected. So that's why I say to understand this pretty much means you have kind of like a PhD degree in math. Not just any math. Okay, you go, not just any math. You go ask a professor, they probably cannot tell you too much about this. You have to specialize in this particular field. And this Chaitin, by the way, this Chaitin guy is also extremely interesting. This Chaitin guy, okay, there is this guy who is kind of a weird guy. This chatting guy. Let me go there. Gregory Chaitin. Okay. He is a friend of Wolfram, Stefan Wolfram, the creator of Mathematica. This is, and he's 72 years old, okay, quite old. And, he study, basically, he is a computer scientist, okay. He's a theoretical computer scientist. By the way, when we say computer science, okay, by default, it basically means theoretical computer science. That is a proper way. Computer science means theoretical computer science. Okay, what I want to say is none of the programmer idiocy. The programmers idiocy. They don't know nothing about computer science. Okay. Okay, I've been talking quite long. So what am I doing good? So I got 7 people watching still. Okay. So anyway, let me finish this. So Gregory Chattin, he's a very interesting guy. So he studied these kind of topics about definability, computability, and things like that. And I first heard of him back in 1995 when I was at Wolfram Research. Apparently, he is a friend of Wolfram, and he's reviewing Wolfram's book, New Kind of Science. They anyway. But so there is a constant named after him, Chatting constant. Let's see, constant. There it is, Chatting's constant. And if you go read that, it's similar to it's a number. Chatting's constant is a number that is not computable. Okay. uh, so let's see what it says. I don't know how do you pronounce that. Let's see. Chaitin. Okay, Chaitin. It should be Gregory John Chaitin. Chaitin. Yeah, Chaitin's constant. Okay, so it says in the computer science subfield of algorithmic information theory, a Chaitin constant or Chaitin omega number. Yeah, that's a name I remember. Chaitin's omega number is a real number that, informally speaking, represents the probability that a randomly constructed program will hold. that's that's a fucking deep concept. Represents the probability that a randomly constructed program will hold. There's so many deep ideas mixed together into that sentence. So it's a number that is the probability that a randomly constructed program will hold. It's a fucking too complex to understand. So these numbers are formed from a construction due to Gregory Chaitin. And this number, it turns out, is not computable. Oh, there it is. Actually, the definition of random number I wanted, the mathematical definition of random number, is this one. It's called Martin-Löf random. Okay. Now you go there. Well, it's probably buried somewhere here. So anyway, this is a very complex topic to, it's a deep topic to study. And it's gonna be endless. It's endless. So I think that's it for today. So we happens upon today's topic is random. And indeed, we have been talking about random. Okay, so that's it, guys. Comments? So Nabi says, you set a newbie in front of Vim and ask them to try exiting the program. that is indeed random. Yeah, and if we measure that, then we'll get the Chaitin's number constant. We'll be able to compute that. Okay, I think that's it for today. Random number, fascinating thing. And by the way, did you know? Now I need to mark it. Xali, a new kind of science. Okay, we're gonna shut down in 1 minute. So I've been reading this book 2 times over the past 20 years. So, this cellular automata, oh, what a fascinating topic. It actually can generate random number. In fact, that's, Stefan Wolf, he's a guy into this very much, so much so that he wrote this book and named it A New Kind of Science. So anyway, so this cellular automata, which is 100% deterministic and very simple, it's just deterministic. And apparently, it generates I think true random number. I don't know for sure. I don't know, but that's a thing. That's why these are so interesting because it's hard to define. Unless you. I mean, even so, this Martin-Löf randomness. Martin-Löf is a guy. Of you guys programmers, Haskell programmers, you'll love it. Okay, because it's when you dive into this, it's all connected. The Martin-Löf is one of the guy who created type theory. There are many branches of type. When you get into math, theoretical computer science, lambda calculus. Okay, lambda calculus is pure theoretical computer science. That originally it was created to study what is computable. Like Turing machines. So that's what lambda calculus is. It has nothing to do with scheme or Lisp. Nothing whatsoever. What would if I can make a claim, what you hear from the Lisp programmers or Lisp programmers mostly when they talk about, oh, this is based on lambda calculus. It's it's pure bullshit, as pure as possible. It has no no basis, no practical or any possible basis at all. That based on lambda calculus, my ass. I don't know if that's, maybe I'm exaggerating a little bit, but anyway. But so anyway, the Martin-Löf guy. So if you just keep reading the Wikipedia. That's what I do. You just keep reading it. You spend 1 hour, 2 hours, read it. Tomorrow you wake up, read it again on random number article, and they have 100 links. You keep reading. If you come across a term you don't understand, try to read it. So you'll get some sense. You have to. Of course, if you really want to learn math or this subject, that's not a good way to go. It's not efficient. You rather begin at some book, textbook, in the beginning, then you advance. But anyway, you can keep reading Wikipedia and about type theory, proof systems, logic, first order logic, foundation of math. Then you'll soon, you'll read about this Martin-Löf guy, type theory and all that. This all kind of connected. Yeah, so this Martin-Löf randomness, this is the definition I am interested about random number. Let's see. So okay. One last thing. Let's see if I can read off a definition of this Martin-Löf randomness. If I can, there it is. Okay. So history. So algorithmically random sequence. History. Okay, let's skip history. The three equivalent definitions. Okay, Kolmogorov complexity. Okay, that's about, that says a random sequence is when there are no shorter programs that can generate it. that's the Kolmogorov complexity definition of random sequence. Then you have, okay, now this is getting into foundation of math. This part I like, okay. And also these constructive martingales. Okay, I don't understand them exactly, but I do get I do get some sense of it. So this constructive neural curves by Martin-Löf, 1966. Okay, so it says this is Martin-Löf's original definition. So it says for a finite binary string W, we get CW denote the cylinder generated by W. Okay, I don't get what he's saying. This is the set of all infinite sequences beginning with W. Okay, it's too complicated. Yeah, okay. That's it for today. Thank you guys for watching. Bye. Let's see how long have I been talking. Okay, 1 hour, over 1 hour. And bye, guys.